Now in this example, we are checking to see if this closed form, that is an is equal to 3 times n plus 2 for every non-negative integer n, is a solution to that to the recurrence relation given here, an equals an minus 1 plus 3. So to check and see if it's a solution, we just have to plug in numbers and see if they match up. So this is kind of the setup we're going to have. Over here on the left, we'll have this closed form, and over here on the right, we have the recurrence relation. So I'm just going to check, 3 or 4 terms and make sure they all match up. So for the closed form, a sub 0 is going to be 3 times 0 plus 2, which is just equal to 2. A sub 1 is 3 times 1 plus 2, which is, 3 times 1 is 3, plus 2 is 5. A2, 3 times 2 plus 2, that's 6 plus 2, which gives us 8. We'll do maybe 2 more. A3 is 3 times 3 plus 2, which gives us 11. A4 is 3 times 4 plus 2, which is, this is 14, but I noticed that I got ahead of myself, so let me correct that. That is 3 times 4. And that's actually good, because what I wanted to point out was how this worked. Okay, the closed form is defined as an is equal to 3 times n plus 2. So when I calculate terms, everywhere there's an n, that's what I plug in right here. So when n is 0, I plug 0 here. When n is 1, I plug 1. When n is 2, plug in a 2. N is 3, plug in a 3. When n is 4, I plug in a 4. And so I get these terms of my sequence. So let's see if we get the same ones on the other side. So A0 is given to be 2. That was part of the recurrence relation. That's the initial condition. A1 is going to be A0 plus 3. That's 2 plus 3, which is 5. A2 is equal to A1 plus 3. But that's 5 plus 3, because A1 is 5. So 5 plus 3 gives us 8. A3 is A2 plus 3. 8 plus 3 is 11. And A4 is A3 plus 3. 11 plus 3 gives us 14. So yeah, all of the terms match up. And so this is a good indication that this is a closed form. This is a closed form solution to the recurrence relation.